Hi, good morning. This is Rajiv Singh, and I have a vast teaching experience of 13 years. And recently, I was teaching in Byju's itself, and I was taking the subject mathematics over there. And I had resigned on 18th of October after working for near to 8 months. And I have done my engineering from Lucknow, and I have done my BTech in information technology stream, and I'm teaching since last 13-14 years. So my today's topic is gravitation, and I can teach maths and physics with full efficiency. So my today's topic is gravitation. Let's start with gravitation. On earth, every two objects attract each other. Okay. Isaac Newton, who was the most influential scientist of all time, once he was sitting in an orchard and he found that an apple fell on the ground. And what did he observe? What did he conclude? He concluded that earth attracted that particular apple toward itself. Okay. Similarly, every two object attract each other in this entire universe. Okay. And they attract each other with the help of gravitational force. That force is known as gravitational force. And when earth attracts any particular object toward its center, then that force is known as gravity. Okay. Newton also gave universal law of gravitation, according to which if two objects of masses m1 and m2, they are separated by a distance small r, then force of attraction F is directly proportional to product of their masses and inversely proportional to square of distance between them. So F is proportional to m1 m2, F inversely proportional to r square. When you will combine, you will get F is proportional to m1 m2 by r square, or F is equal to capital G m1 m2 by r square, where capital G is a constant which is known as universal gravitational constant. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kilogram square, and F is equal to G m1 m2 by r square. I have told you. Okay. Now suppose we have to establish the relationship between acceleration due to gravity small g and capital G. Since according to Newton's second law of motion, you know that F is equal to ma. But in case of gravity, we can write down for mass of m object, for object of mass m, F is equal to small m into small g, where g is acceleration due to gravity. This m into g will be equal to capital G, gravitational force, capital G into capital M, mass of earth suppose, into small m, mass of object, upon r square. So small g will be equal to capital G into mass of earth upon r square, where if the object is kept on the surface of earth, then small r will be considered as the radius of earth, and small g is equal to g into mass of earth upon radius of earth square. And when we solve after putting the values of me and re, we get small g is equal to 9.8 meter per second square. Okay. Value of g, it varies from place to place. Okay. It is maximum at poles and minimum at equator. Free fall state, when an object starts falling freely under gravity, then the state of object is known as free fall state. What do you mean by weight? Weight is that particular force with which earth tries to attract any particular object toward itself. So I hope you must have enjoyed the brief introduction about the gravitation, and in our next session we will discuss the equations of motion under gravity. Newton's equations of motions were V is equal to u plus at, S is equal to ut plus half at square, and V square is equal to u square plus 2as. Okay. When an object moves in upward direction, then it will become V equals u minus gt. h is equal to ut minus half gt square, and v square is equal to u square minus 2gh.